Hi everybody. We're gonna trade and grade the calculating R with dry ice lab, so please take yours out and trade with a partner. First we're gonna do the headings, so as always it's 1 point. They need their name, partner's name, lab title, date, and lab station number. The purpose is also 1 point, so it was to calculate the ideal gas law constant, or R, using dry ice. Procedure, all they have to write is C handout, that's 1 point. The data is 10 points. It should match what it says in the lab handout there. There were 10 things that they needed, so make sure that they have units. Calculations are 2 points, so their first calculation is the value for R. So they should say R is equal to P times V over NT. And then the second calculation is the percent error, so observed minus accepted over accepted times 100%. And of course the accepted value was 62.4 millimeters of mercury times liters per mole Kelvin. So back to their data table, if they don't have units for any of them, or if the units are incorrect, minus half each, and that includes the value for R. For the conclusion, it is 5 points, so they should have their observed value for R with units if they don't have the correct units. Again, those are millimeters of mercury times liters per mole Kelvin. If they don't have their units, or if they're wrong, it's minus half. Same thing for the literature value, it's 62.4 millimeters of mercury times liters per mole Kelvin. If they don't have units, or if they're incorrect, minus half. They should state their percent error, it's worth another point. And then a source of error and how the error affected the results, whether it was higher or lower, and how it affected their R. And it should be consistent, so if their value is higher than 62.4, they need to select a source of error that would make it higher, and so on. So on the next slide are my different sources of error that I came up with. So here, if your value is lower than 62.4, the temperature that you recorded was probably of the room. The gas itself was a little colder. So the temperature that we recorded was a little bit higher than the actual temperature of the gas inside of the bag. Or the pressure that we recorded was lower than the actual pressure of the gas inside of the bag, because again we recorded atmospheric pressure, the pressure in the room, which was probably a little bit lower. The gas in the bag had a higher pressure. Another source of error could be that some of the water was lost in transfer from the bag to the graduated cylinder when measuring the volume of the bag, and therefore the volume of the bag was that was recorded was too low. So this would be if you filled up your bag first with water and then you transferred that water into a graduated cylinder, and then that would be the case. Or more of the dry ice sublimated quickly and escaped as CO2 was being pushed out before the second massing. So before your second massing, your bag was inflated with CO2, you pushed all that out, but maybe before you closed it, some extra dry ice had sublimated and escaped. If your R value was higher than 62.4, then here are some sources of air. So maybe some air was left in the bag, so it didn't allow as much dry ice to sublimate, which affected your grams. Or maybe some of the water was lost in transfer from the graduated cylinder to the bag when measuring the volume of the bag. So your volume was too high. So this would be the case if you filled your graduated cylinder with water and then you transferred that to the bag, as opposed to this one was the opposite, if you filled your bag first and transferred it to the graduated cylinder. The total for this lab is 20 points. So if you're comfortable grading it, give them a total and put it on top out of 20, and then write your name as the grader on the bottom.